good afternoon, and I'm delighted to be part of this panel. What I'm going to try to do is bridge a bit what you heard from Mario about the data. What kind of information do we need to begin this process and carry it all the way forward to dietary guidance or to nutrient reference values? And why do we want to do that? I think, number one, if we think about ourselves being involved with nutrition, excuse me, we want to provide consumers with guidance about healthy food choices, and we can do it via education and, importantly, by food product labeling as well. But in addition, if we have this kind of information and we codify it appropriately, as Mario was describing, we can provide the nutrition industry with definitions that guide innovative new product development, as well as truthful and non-misleading communications about products. We need that data to do so, and we need to collect that data appropriately. So a favorite quote of mine from the German philosopher Goethe, which happens to be on the cover page of every dietary reference intake book, said, "Knowing is not enough." Well, how much do we have to know before we begin to apply this information? Excuse me. And willing is not enough, we must do, but I think the critical information for this session this afternoon is, how do we know what we know? How much do we need to know before we can begin to apply this information? So you already heard from Mario in part about the challenges of using the appropriate analytical methods, the appropriate experimental designs, whether we're talking about experimental studies or intervention studies. The critical need to use the right nomenclature, which would seem self-evident, but if you read the literature, you'll see it can be confusing. Appropriate quality control and measurements, and then, of course, reporting things, and just to underscore what Mario said, reporting everything you've got, if we can do that. And many journals with their online supplements now allow you to put up much more information than in a print version of a journal. But we want to move from the data that you can generate. I just want to say a few words about food composition analysis. A blueberry is not a blueberry, is not a blueberry. I mean, is it a high bush blueberry or low bush blueberry? Was it farmed by organic methods or by conventional agriculture? What country was it grown in, or what region of what country? These make a difference when we talk about composition. And I think it also means we have to get comfortable that we can't know everything. That's too much information, or too much to expect us to realistically get. But we have to understand there are those differences. And of course, there are the environmental and geographical ones: climate, soil, water, and so on. And just as importantly, all of the post-harvest information. So when we start talking, we like to refer to from the farm to the table, but lots of times it goes from the farm through all sorts of handling processes. So when you do your analysis, well, if you do an analysis of your product that you're going to use in a study, that's easy. But if you're looking for databases, where are you starting to look at those measurements? Sample preparation is critically important, and different preparations are going to give you different outcomes. And I think we don't know very well about sample size, particularly if we're on the farm or out in the field. How many, to stay with blueberries, how many blueberries do you have to collect, and from what regions of the farm, and how many different farms? These are all issues that I think still need to be dealt with, and how many times do you need to replicate that before it's really suitable for putting into databases, for example. So as we move from the food composition, that next step, which I really wanted to focus on, was databases and how we classify and organize flavonoids. Heard a few times, I think, in this conference about the accuracy of the data. When we are dealing with all those issues that I just raised, I think accuracy is not a realistic goal when we talk about the available food databases, and hopefully it will change a bit in the future, but you must be comfortable with relative standard deviations of 30%, 50%, maybe more, because that's the variation that's out there in the real world and need to be evident in those databases. We heard Eric Rimm say earlier today that he wasn't sure about each one of those quintiles, but he was pretty confident that those people in the 5th quintile were eating a lot more of, I think it was anthocyanins than those in the 1st quintile. Well, that's pretty good. I think we can use that kind of information. So I think we want to strive for accuracy, but understand that we're not going to achieve the kind of precision that you can get if you're doing a specific experimental study in your own laboratory. The issue of the nutrient databases containing the data as aglycones versus the glycones, we really have to have as a goal the inclusion of the glycosides information into the databases, and that is a goal. I think we heard Augustine Scalbert talk a little bit about some of the future directions for the Polyphenols Explorer. Nomenclature, again, we don't do the nomenclature right in your publications. It doesn't often get translated appropriately then into the databases, and we have a problem. With regard to incompleteness, I think I can tell you with some confidence that every database that we have right now is incomplete. Every database that we will have in the next 10 years will be incomplete. I think we just have to get used to it. This is far too complex. There are far too many different plant foods, to use the example for flavonoids with all of their cultivars. We do not have the information yet, although it is being developed on the metabolites in addition to the parent compounds. We do not have information in many of these databases on country of origin. So the databases are incomplete. That does not mean we can't use them even as incomplete. And we heard talks earlier today about the epidemiology, observational data. It's coming from these databases, and I think we're getting some very interesting and valuable data even when we don't have everything that's complete and accurate. So when we talk about the flavonoid databases, I presume everyone here is familiar that there are 3 separate flavonoid databases put out by the U.S. Department of Agriculture, flavonoids, anthocyanins, and isoflavones. It's just historical precedent that they got divided in that way. The Eurofers Bioactive Substances in Food Plants Information System is remarkably comprehensive and goes far beyond just flavonoids and polyphenols, but it's got a lot of terrific information. And then the Phenol Explorer, which I just mentioned, and again that we're learning here about some of the really ambitious goals about expanding and extending that information. So the point of the databases, of course, is to provide the foundation for dietary intakes. And there we have a number of assessment tools: food frequency questionnaires, diet diaries, 24-hour recalls. We need to use all of those tools, I think, to get the best intake available, but I think it cannot be used blindly. We have to understand, and we've heard lots of talks in the last few days about the marked inter-individual variability in bioavailability and distribution, and so on. You have to keep that kind of information in mind. And then, of course, there's the reliability which we need to validate these tools for these databases. So one of the, I think the other point I wanted to make there is, because it's not evident in all of the dietary assessment tools, tea consumption is not tea consumption. Are we talking about green tea or black tea? Are we talking about ready-to-drink tea or freshly brewed tea? If you don't have that kind of quantification in your assessment tools, you need to recognize the limitations of that. So this is data you've probably already seen coming out of the SU.VI.MAX study looking at the dietary intake of polyphenols in French adults. And the thing I really want to point out here, if you can read it, is the right-hand column, the main food contributors, the percent of the contribution to the intake of the subclasses. This information, I feel, is really important. If you just report the flavonol intake, the anthocyanin intake, if we're going to start using that data from one country to another and understanding all that complexity about food types and food matrices, you can't do that readily if we don't know what foods you're really talking about. So I think including this kind of information, the major food contributors, is really important as we move forward in this field. So I think I already alluded to the importance of validating the exposure, that is, validating the use of these flavonoid databases. And we can use all sorts of tools looking at different matrices like blood and urine, the pharmacokinetic data that's coming out, and now we realize that these things aren't necessarily all absorbed in 2 hours and disappear 2 hours later. So the understanding of the pharmacokinetics is important not only in experimental designs, but in using these kinds of information in observational studies. I think we lack a lot of information on single versus multiple exposures, but that's one place where I think that observational data, using these kinds of databases where we look at frequency of intake, can provide some useful information to explain those outcomes. So this recent report by Zamora-Ross et al., looking at the InCHIANTI study in Italy, and they were looking at the survival probability here, and you can see that the total urinary polyphenols provided a useful information. Those with the highest, the highest intake of, the highest excretion of urinary polyphenols, had greater survivability, longer survivability than those who didn't, but it didn't match with the dietary intake. But maybe the total dietary polyphenols might have been the wrong measure. Maybe we start looking at specific subclasses for that information. Thanks. So the other component, is intake, and I think it's really important, and the points I was trying to make underscore this, of looking at national versus international cohorts, more important on the computer, and this huge issue of duration. We're talking about soy studies in Asia and soy studies in the West. You just cannot make the same assumptions that a short-term study you're doing is relevant. So then moving to function, the next step, once we've got that dietary intake data, and Doug alluded to this. There are 3 different kinds of approaches: maintenance of physiologic function, maintenance of normal health, modification of intermediary biomarkers, reduction of disease risk. These are not the same thing. They may overlap, but they're not the same thing. And so when we want to talk about moving towards dietary guidance or nutrient reference values, we need to think about which one or more of these kinds of outcomes we want to focus on. And one way we can make that decision is, where is the evidence best? So this is a meta-analysis of 15 trial arms of cocoa flavonols reducing pre-hypertension, reductions in both systolic and diastolic blood pressure. How many studies do we need? How much knowledge do we have to have before we begin to act? And this kind of meta-analysis points out something that I mentioned before. We need a range of intakes. So we're talking about here a 5-fold range of intakes of flavonols, 30-fold range of total polyphenol intake. So we have lots of studies, we have lots of ranges and lots of ages. Aidan Cassidy presented some of this information this morning. Once again, a large cohort, over 150,000 people, 14 years of follow-up, and again, we're talking about more than a 4-fold range from the bottom to the top quintile, where we have more confidence about then evaluating that data. I'm not picking on you, Aidan, and we just have really good studies here, and I think this one was presented as well. And once again, 18 years of follow-up in this study, ranges of 10-fold between the bottom and top quintiles, very much similar kinds of range when looking at the polymers. We've got a lot of data, so it's observational data, it's confounded. That doesn't mean that it's not very useful and very worthwhile as we think about things like reference nutrient values, where should they be, and dietary guidance. So how do we move to that next step? Well, we do have frameworks for nutrient references and risk factors. We have the FAO, WHO Codex Alimentarius. The U.S. Institute of Medicine has the dietary reference intakes. I think one question is, do bioactives, do non-essential nutrients that don't prevent deficiency diseases, can we use this kind of approach for these very different kinds of compounds? And while I'm not going to give you an answer, I think that's up for discussion, they certainly give us a framework for how we should move that discussion forward. So you may all know that the IOM framework is the DRIs, including the estimated average requirements and adequate intakes. And the AI are defined as when sufficient evidence is not available to set an estimated average requirement. I would argue that we're certainly there when we talk about flavonoids, but then the AI becomes the goal for the intake of individuals. I just want to emphasize that the AI is expected to cover the needs of most all people. Not 97%, but most all. And in the discussions about AI, it says it really suggests it should be set at a maximal amount where it would cover everyone and reflect the highest intakes that are common. In Johanna Dwyer's presentation, she ended it with saying, well, let's not forget about safety and risk. The DRIs include the tolerable upper intake level, highest level likely to pose no risk of adverse health effects. The FAO, I don't think they've actually applied this much, but there is the conceptual highest observed intake, where no toxicity has been observed, the highest dose tested that can be confidently concluded as safe. Safety is really important, because if we move towards dietary guidance, if we move towards nutrient reference values, we're going to look at the benefit versus the risk. And if there is risk, our confidence in applying those values will be more limited than if in fact they are really quite safe and the benefit perhaps modest. So I would just conclude, since I started with a quote from a German philosopher, I'll end up with a French one. The perfect is the enemy of the good. I have tried to describe some of the enormous complexity of flavonoid analyses, putting them into databases, using them in studies, but just because we have that complexity doesn't mean we have to wait for another 5, 10, 15 years until we're more accurate, until we have more information. I think the idea of starting to develop now a framework for moving forward is perfectly reasonable. So don't let the perfect be the enemy of the good. I think we really need to move forward on that. Thank you very much.